In this video, we're computing the average value of cosine squared x on 0 to 2 pi. Now, because this function is periodic, actually with a period of 1 pi, the average value over any integer number of periods will be the same, so we can just think of this as the average value of cosine squared. And the average value of a function really just means the constant function that would enclose the same signed area as the original function. So there's the area bounded by the original function on 0 to 2 pi, and we're just trying to find the constant function bounding the same area, in other words, this horizontal line. So we'll call that f bar, and the area bounded by f bar is just the width of the interval multiplied by the height, because the enclosed area is just a rectangle. So now all we have to do is relate these two areas. And the area bounded by our constant function, again, is just given by the height of that constant function, that's f bar, that's what we're trying to find, times the width of our interval here, which is 2 pi. And that has to be equal to the area bounded under the square of the cosine function on 0 to 2 pi. Well, that's an integral from 0 to 2 pi of cosine squared x dx. So we find that our average value of the cosine squared function is just 1 over 2 pi times the integral from 0 to 2 pi of cosine squared x dx. And this is a classic trigonometric integral. The way you solve these is by using an identity for the cosine squared. We can replace cosine squared x with 1/2 times the quantity 1 plus cosine of 2x. So while I'm doing this, I'm going to pull a factor of 1/2 out in front, and I end up with a 1 over 4 pi out in front. And we have the integral from 0 to 2 pi of 1 plus the cosine of 2x dx. Each of those pieces is simple to integrate. The first just gives me an x. And then the second piece, I'm trying to get the antiderivative of cosine 2x. That's basically sine 2x. But I need a 1/2 out in front to account for the chain rule. And this whole thing is evaluated from 0 to 2 pi. Now, if I look at the lower limit of integration, I substitute 0 for x, and I get 0 out of the first piece, and then sine of 0, which is also 0, out of the second piece. So everything vanishes when I sub in that limit, and I don't have to worry about it. Then I think about the upper limit, and if I sub in 2 pi for x in that sine function, it gives me the sine of 4 pi, which is also 0. So that term is gone. The only survivor here is subbing in 2 pi for x in that first term. So I end up with 1 over 4 pi times 2 pi, and that's just 1/2. So we found out that the average value of the square of the cosine function is just 1/2, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.